9.5 meters below space and time. This crash did it. So how much interest? Well, I'm going to take this vector equation. Alright, so today we're going to be analyzing the insane gravity in a Roblox game called Adopt Me. And here's how we're going to do it. Enjoy. Alright, so there's a Roblox game called Adopt Me where you can buy an anti-gravity potion. My question is, does this anti-gravity potion actually reduce gravity for you? Or does it simply give you super strength to be able to jump with a greater initial velocity? This is what we're going to test. So how we're going to test this, you can see in the background here, I have my friend jumping up and down, and then she jumps on a trampoline up and down, and we're going to use that as our control. Then she's going to drink an anti-gravity potion, go back and jump up and down again. Finally, she'll drink another anti-gravity potion and do the same thing. And what we're going to do is we're going to compare the effects of gravity as she's jumping to see if she really does reduce gravity in her vicinity due to that potion, or if she's giving herself a greater initial velocity to start off with. And make sure you stay tuned because the results completely shocked me. Alright, so in our analysis, which I have going at super fast forward speed here, is I initially choose a height, a distance that I know of. So what I did was I chose my friend in the background there, and I made her height about 1.6 meters, which I thought would be the, an average or approximate height for an adult woman. And so now we have a scale that we can use that's in our metric system instead of in pixels. And then I plot her position for one jump, a normal jump, which makes a graph, as you can see that first small blue graph. And then I plot her position throughout one jump on the trampoline. And then I plot her position one jump after drinking an anti-gravity potion, and then again one jump after drinking our second anti-gravity potion. Now let's analyze our results. Alright, so now that we have our data set here, let's start to analyze it. So I have 4 jumps here. First one is just a normal jump. The second one, this big one here, is with a trampoline. This is with 1 gravity potion, and this is with 2 gravity potions. So our question is, do the gravity potions actually decrease gravity, or do they give us super strength to jump up with a greater initial velocity? Now our A coefficients of these curve fits that I had the software put in would be half of gravity. So for example, on the trampoline, the A coefficient is 22.94. Multiply that by 2, you get 45.88. Now that in itself is amazing. That's about 5 times what the force of gravity normally is here on Earth. So either something's wrong here, or all these robot characters are incredibly strong to be walking around in 5 times normal gravity. I don't think I could do that. So let's do a little test here to make sure this is true. So I'm going to do a quick calculation on this trampoline jump, since this is the one that goes up the highest. I'm going to find the total height that we went to. And to do that, we're going to look into our data set here. So our total height, so our displacement in y, is going to be final minus initial. So our initial point, it looks like we're starting off right here at 0.8192 meters above the origin that I set there. So let's subtract that 0.8192 meters. And then we need the highest point that we go to, so we'll just check in our data. And right here. 26.49. We don't go higher than that. So that's the maximum height that we went to. So let's find that maximum height. So if we subtract these two values, we get 25.67 about meters. So that's the maximum height we went to. That's a pretty good jump. That's a fun trampoline there. Now let's figure out the time it took to actually reach that height. So we do the same difference. We take the final time, which is here 11.08 seconds. So 11.08 seconds. And we're going to subtract the initial time in our data. If we go back up, right there, 10.04. So we're going to subtract 10.04 seconds, and we get a time of 1.04 seconds. Now our y velocity at that peak there is going to be 0. So having these three pieces of information, we can figure out the acceleration due to gravity to see if it matches our a coefficients, if it matches our curve fits or not. All right, so we'll use this motion equation. Delta dy equals Vf delta t minus 1/2 a delta t squared. Now Vf is 0, so this whole term is going to disappear for us. And then if we multiplied both sides by 2, we'll get 2 delta d. Divide both sides by time, so divided by time squared, and that gives us negative a. All right, so let's sub in 2. I'm just going to do this over here because I've run out of space. 2 times delta dy, which we've calculated, is 25.67 meters, divided by time squared, which is 1.04 seconds squared. And that gives us 47.7 meters per second. So a would be negative 47.7 meters per second compared to the negative 9.8 meters per second here on Earth. So yeah, about 5 times as strong. If we look at the a coefficient here, it's negative 22.94. Now the gravity would be twice that a coefficient. So if we do twice of 22.94, that would be 45.88. So 45.9. Okay, so let's compare. 45.9 meters per second squared, forgot my squared here, with 47.7 meters per second squared. I think those coefficients are a very good approximation. There's just a little bit of experimental error involved, but that's it. All right, so if those coefficients are a good approximation, let's look at those coefficients to see, is gravity changing? So on our trampoline, we had 22.94. So twice of 22.94 would be a gravity of, like we said here, 45.9. Now here, on the normal jump without the trampoline, we get 25.59. So that's about 51, or 51.18 if we double that. So it looks like gravity isn't really changing much, which it shouldn't. If we jump on a trampoline, gravity doesn't change. Right? There's a little bit of error there, but I think we can chalk that up to experimental error. Right? We're comparing about 46 and 51 meters per second squared. Now the big difference comes when we take our first anti-gravity potion and just jump. This is 11.99, which is about 12. Double that would give us gravity, which is 24. 24 meters per second squared, I would say, is about half of what we got in our first two examples where we did not take the anti-gravity potion. So that's not something we can chalk up to experimental error. That's half. And then again, we go from about 24, or 2 times 12, to about 2 times 6.5, which is 13. That's about half as well. So when we took our second anti-gravity potion, it looks like we reduced gravity by half again. So it looks like this Roblox game really is reducing the gravity on you by half every time you take one of these anti-gravity potions. Okay, so it looks like then we don't become super soldiers or anything like that here by taking anti-gravity potions, but I think I would like to say that these Roblox characters are super soldiers straight from the beginning. Like I said before, without anti-gravity potions, that's about 5 times the gravity here on Earth. You'd have to take 2 of those anti-gravity potions just to get to something similar to what it is here on Earth. And they're walking around and running around and jumping in this gravity. So when they jump, what kind of initial velocity is required? So let's check this, because I'm quite intrigued by it. So if we're going to find out initial velocity, let's do this first jump here without the trampoline. This initial jump here, we're going to find initial velocity using this equation. VIY delta t plus 1/2 a delta t squared. Now I'm going to do it for the entire jump up and down. So if I'm going to take the time for the entire jump, that means the displacement in y is going to be 0. So I can get rid of that displacement, and I'll bring one term to the other side. So you'll get minus VIY times delta t equals 1/2 a delta t squared. And I know time is not going to be 0, so I can cancel one of those times out. And I will get initial velocity, if I bring the negative over, equals negative 1/2 a times delta t. But I want to look at this negative 1/2 a. I'm going to just not worry about the negatives, because each value for a is negative. So when I plug in a as negative, it's just going to cancel out. And 1/2 a is our coefficient, our capital A coefficient in our quadratic trend. Okay, so I can simplify this to just saying the initial velocity is the absolute value of that A coefficient, just ignore the negative, times time. All right, so for our first jump here, our A coefficient is 25.59. 25.59. We'll negative that, but I'm going to take the absolute value of that. And that would have units of meters per second squared. And then times the time interval for the entire jump. So that we need to look at. So the time interval, it looks like we are starting the jump at 10.04 seconds. So it's always going to be final minus initial, so minus 10.04 seconds. And if we go down in our chart here to find out where we finished the jump, we finished at, oh, sorry, I was doing the first one, wasn't I? Let's go back and look at the first one. All right, we're doing the first jump. So the data for the first jump is we finish at 4.120 seconds. So 4.120 minus that initial time, which is up here at 3.560. So when you calculate that, we get an initial velocity of 14.33 meters per second, multiplied by 3.6 if you want to know kilometers per hour, and that's about 52 kilometers per hour. That's incredible. They jump upwards with an initial velocity of 52 kilometers per hour. It's like every one of these little Roblox characters is like a Hulk inside, which under normal Earth gravity could jump up to tall buildings. It's incredible. Now I did this exact same calculations for each jump. On the trampoline, we get an initial velocity. So on the trampoline, we get an initial velocity of 175 kilometers per hour. That's to be expected. A trampoline should provide a larger force over a larger time period to give you the greatest change in your velocity. And like I said before, that's one fun trampoline. Now for the other 2 points without the trampoline, but with less gravity, I got values of 64 kilometers per hour and 54 kilometers per hour. So let's compare those. So 64 kilometers per hour and 54 kilometers per hour. So without the trampoline, I get values of 52, 64, and 54. Those I think we can say are fairly consistent, right? If we take into some experimental error there. So the initial velocity seems to be fairly consistent, somewhere between 52 and 64 kilometers per hour. So the anti-gravity potion definitely does not make us stronger, although they're already super strong because they're doing all of what we normally do in 5 times Earth's gravity. So I hope you enjoyed that. If you have any other video games you want me to analyze or are curious about, let me know in the comments.